Hello, Year 4, and welcome to another geography lesson. Today we're going to talk about the formation of mountains. I've decided to film this not at my kitchen table as normal, but in the room that I have painted with mountains. I wanted to show you exactly how much I love mountains. I love it so much that I've painted them in my house. So I'm excited to give you this lesson, and let's get started. Let's first, before we talk about mountains, talk about what's underneath them. So let's talk about the structure of the earth. Take a look at this picture. This is like as if you took a slice out of the circle of the earth. Or sorry, it's a sphere. When you talk about 3D shapes, it's called a sphere. So this is the sphere of the earth, and has a section cut out. It has 4 layers to it. The layers are crust, inner core, outer core, and mantle. But my question to you is, which label here at the bottom left, that way, bottom left, goes to which line? Those lines are labeling the structures of the earth, but can you choose which words go where? Let's take a look. Crust, mantle, outer core, inner core. So the earth is made from 4 distinct layers: the inner core, the outer core, the mantle, and the crust. And each layer has a different thickness and is composed of different materials, which have different characteristics. And so we're going to take a look at those now. There is the inner core. So you can see that word at the bottom. The inner core is the center, and it's primarily made out of a solid ball of iron. That's what the middle of our earth is. And it has a temperature of 5,500 degrees Celsius, which is almost as hot as the outer layer of the sun. Isn't that cool? The outer core is composed of iron and nickel, and it's unlike the inner core because the outer core is actually liquid. Then there's the mantle, which is the thickest part of the earth, but the mantle is viscous and composed of semi-molten rock or magma. Think about viscous as like if you poured honey out of a jar, how it comes out kind of gloopy. That's what the mantle is like. It's kind of gloopy. Or you can think of magma coming out of a volcano as lava. And that is what the center of our earth is. Then laying on top of that is the crust. It's the outer layer of the Earth's surface, and it's the thinnest layer. Now, the crust is composed of solid rock, and it rests on top of the layer of mantle, and is about 60 kilometers thick. And if you think about 60 kilometers on top of the Earth, it would be like from here to Brighton or here down to the coast, straight south. But instead of going across the earth that way, you have to think about going straight down into the earth. That's 60 meters. Oh, sorry, 60 kilometers. Now, here are the Earth's major plates. You've already done this lesson. You've already made really wonderful maps of the Earth's major plates. But let's take a look at them again. So, the Earth's surface, or the crust, is not one smooth, unbroken covering. It's made up of different sections called plates, kind of like a cracked eggshell. There's 8 plates floating on the mantle, and they are the Eurasian plate, the Pacific, Indo-Australian, Antarctic, Nazca, North American, South American, and African. But here's a couple questions that I want you to look at. Take a look at that picture of those plates and tell me which plates contain, sorry, let me try that again. Which plates include more than one continent so they don't actually just mark the boundaries of a continent? So let's take a look. I'm going to move my picture for you. Take a look at that Indo-Australian one. It has a bit of the Asian plate on it, and the Asian continent on it, and it has the Australian continent on it. Now, I had to make my picture go away so you could see it. And now take a look at the African plate. You can see that it has only just the continent of Africa on it. Or another example is the North American plate. My next question is about which plates are actually just oceanic plates? Can you see any? Take a look at that Nazca plate or the Pacific plate. Those just lie underwater. That doesn't mean that there's nothing on there. There's still rock underneath the ocean. So the ocean is sitting over rock, but these plates are just the rock underneath the ocean. So they don't have rock coming up above the ocean level, like behind me. They don't have continents coming up. They have some islands, though, like Hawaii is in the Pacific. So the really cool thing about the Earth is that the Earth's plates are constantly and slowly moving. So how do you think this happens? Let's take a look at the next slide. Oh, sorry. Let's take a look at this video. Here's an example of Pangea. This is Pangea if we had the same borders, but when Pangea existed, they didn't have borders. But do you see how we can see North America here? Here's the United States and how it slots in right next to the African continent, or how it also nestles right into the South American continent. So we can see that those pieces of land almost, how they nestled into each other. I just thought that was a really nice image. Now let's take a look at how how everything moves on the Earth. So this is another cross section of the Earth. So we've cut the sphere and we've cut a bigger chunk of it out, and we're looking straight into the middle of it. So underneath the crust, what we're standing on, underneath the Earth's plates, it's constantly and slowly moving. And there's something called convection currents in the mantle, and they cause the plates to move. So heat rises and falls through the molten rocks that compose the mantle. And as the magma moves, so do the plates. The Earth's plates are constantly moving. On an average, they're actually moving 1 to 10 centimeters per year. Kind of if you imagine, if you ever looked into custard or into porridge that's bubbling, it's actually doing that underneath our crust and moving our tectonic plates a little bit. All right, but how are mountains formed? So you've already done this in the first lesson, but I didn't do a video for it. So now we're going to take a look at how these mountains are formed. The first one, you've tried an experiment just the other day where you took towels, different colored towels, and laid them on top of each other, and then you pushed them. When you did that, you made a fold mountain. So first of all, mountains are formed because occasionally two of those plates move closer to each other or converge, and this creates intense pressure, causing the plates to buckle in different ways, and they form a mountain. So the different ways to form is you can either form fold mountains, fault block mountains, or dome mountains. So fold mountains were formed over millions of years ago. These are the most common type of mountain, and they are formed when two plates move towards each other, and it causes the plates to buckle and push the crust upwards, forming a mountain. You can imagine the towel kind of going bloop. That's a buckle when it did that. An example of that is a Zagros mountain, and also the Himalayas are another good example of a range of fold mountains. They're formed 25 million years ago when the Himalaya plates, the Himalayan mountains. Let me just show you an example. Those are the Zagros. But the Himalayan mountains were formed 25 million years ago when the Indo-Australian plate pushed against the Eurasian plate. So you can actually find fossilized seashells up in the Himalayas because it shows how actually it was push, and formed and out of the seafloor and actually pushed all the way up into what they call the, oh my gosh, sorry, I forgot the name of it. All right. Other examples of fold mountains are there's the Andes, there is in South America, there's Mont Blanc in the Alps in Europe, and there's the Rocky Mountains in North America. Those are all types of fold mountains. This in back of me isn't a real mountain, but I think that you can call those fold mountains. All right, so the next one is the fault block mountains. Here's the fault block mountains. So we can see that there's plates, there's a fault line that's been formed by the pressure, and as the plates keep moving towards each other, that center section is forced upwards. And then the last step, why doesn't it look like this when we look at mountains, is because over many, many years, the erosion forms the mountain shape. So it gets rained on, it gets snowed on, glaciers pull it down, and it looks more like that. But they're formed when two plates move towards each other rather than the crust folding under the pressure of the moving plates. And it cracks along the lines that are the weakest, and these lines are called fault lines. And the crust then breaks into blocks along these fault lines. Real-life fault block mountains do not form in straight lines. You can walk between the tectonic plates in Iceland. Do you remember that video from English if you've watched it already? And so that's an example of kind of the weak points in the fault lines. But then how does it doesn't look like straight lines when it's a mountain. So how do you form that? It's called erosion. And so it's the continual wearing away of rock by rain, ice, and wind over time. And it changes the shape of the rocks and the land. And one of the mountains that have inspired me to do this painting behind me are the Sierra Nevadas. And they're a mountain range in California. So the Sierra Nevada mountains are an example of a fault block mountain. Let's take a look. Here's a picture of the Sierra Nevadas. Love them. All right. And here's our last mountain, which is called a dome mountain. And I bet you already can tell how it's formed. Dome mountains are the result of a great amount of molten rock or magma pushing up from under the Earth's crust. And without actually erupting onto the surface, the magma pushes up the overlaying rock strata, so the layers of rock. And at some point, the magma cools and forms a hardened rock. So the uplifting areas created by the rising magma is called a dome because it looks like like a half of a ball. And the example we have here is the Black Hill Range in South Dakota. So here's Bear Butte, and there is Mount Rushmore. And Mount Rushmore is some American presidents have been carved into the side of a mountain, into a dome mountain to be exact. So those are our mountains. You are now going to go into the Google Doc and you are going to complete the sentences that are below each picture of the mountains. You're going to, the diagrams, I'm sorry, there's going to be diagrams of mountains. And there's a sentence with blank lines, and you're going to erase those blank lines and fill in the blanks. All the words are there for you at the top. There's a vocabulary list, and you can use those words more than once. Then I'd like you to follow up with that by trying to make a 3D model of the earth or a mountain. Sorry, I'm missing the E here. Okay, that is it. Good luck with your work.